All right, let's get started. 1 second. All right, I've got the headphones on today. it's rather nice having the headphones on because it feeds back my microphone, which helps remind me not to scream too much. All right. Hello, everyone, chatting in our little chat here. It seems that some of us are sad, which is that's a nice feeling. Well, okay, that sounds very bad out of context, naturally. But I hope it means that we've had a fun time during the term, or we've learnt some interesting stuff. And we are now getting proposals and petitions for COMP6991N. It seems for what have we got? Advanced Rust, Unsafe Unsoundness, Async Rust. Yes. Can I turn it up? Oh yeah, actually I was messing with it earlier. Let me turn this up and this down. I think, is that slightly better? I might need even a little more. Maybe something like that. You might hear more of my keyboard now though, but that's alright. Some people like keyboard noises. Okay. Artemis Launch. Is that some kind of rocket or something like that? Actually, speaking of, we'll probably be doing some rocket stuff today in our second for fun lecture. Moon launch. Oh. Okay, awesome. 20 minutes ago. Wow. Okay, cool. Assignment 1 requires you to generate your code using a macro. Yes. Wow, okay. T plus 20. Wow, awesome. All right. So, welcome to our last lecture. We had a lot of fun on Monday. The slightly chaotic lecture, and don't worry, I am perfectly aware that it was a relatively chaotic lecture. Async Rust is not really something that I ever envisioned being able to teach during COMP6991. And so if all I do is confuse everyone, attempting to teach it, then my deepest apologies. But if some of us get something from it, from me rambling on about this stuff at all, then it's still a win as far as I'm concerned. We were out of actual legit content at the end of week 9 anyway, so this is all just for fun and for what people are interested in, and a lot of people seem interested in async Rust. So as a reminder of what we talked about on Monday, like 3-minute recap, we talked about the future trait. The future trait, I think, is pretty cool. Oops, I always do that. The future trait is pretty cool. The big idea of future is that it's an abstraction over the idea of a concurrent operation. It's in particular Rust's idea of what that abstraction should look like. Rust, we know, is hallmarked as a language that doesn't like to be implicit about potentially serious costs, I suppose, is one way of putting it. Serious, for some value of serious, probably a lower value than you're used to. We know this with things like the distinction between string and stir, and the fact that if you usually have to state pretty clearly at some point if you want to turn a stir into a string, whether that's with a clone or with a .toString or something like that, just because, well, one of the big reasons being that Rust considers allocating to be expensive in performance or memory usage, that kind of thing. And so it likes to be very explicit about where the costs of your program are most likely going to lie. And sort of following on with that trend, we learnt that Rust futures are relatively bare bones. Compared to, say, like JavaScript promises. JavaScript promises are interesting because they are also an abstraction over the idea of a concurrent operation. But something interesting about promises is that as soon as you instantiate one, as soon as you create a new promise, it's immediately set to work. You don't need to actually, keep track of the promise or keep on prodding it to do more and more work. It'll just do work over time. As soon as you create it. Whereas a future with Rust does need to be prodded to like make some progress. Now, and that, it falls quite closely into Rust's idea of we don't want implicit weird things happening in the background. We like to be very upfront with our code and have it try and be obvious about what's going on, that kind of thing. And so that certainly influenced the design of Future quite a lot. Otherwise, so something I'm not sure if I talked about it to the extent I would have liked to, but I think I may have mentioned on Monday that usually in Rust, when you're writing asynchronous code, for example, when I'm writing Rust code to power things like the course website, let's say, that's kind of necessarily async. I could have written it without any async, but I think it makes it a lot easier for me, and also makes the website a lot more scalable if I write it asynchronously from the beginning. And the good news is that in writing this whole course website, I never actually had to use the future trait directly myself. And that's sort of like an aspiration of Rust in the long term. That users, when you're writing a library, maybe things might get a little more complex, but if you're just sort of writing like business logic kind of code, you're making a website, that kind of thing, you should just be able to use things like async, await. You shouldn't hopefully need to delve too deep into these details of stuff like future. And I can say that, in writing this entire website, for example, I've never had to touch future itself. I just leave all that work to my asynchronous executor. For most people, that ends up being a library called Tokyo, which we're going to talk about today. And then it handles, most of the inner details and the low-level aspects. And I just get to focus on writing high-level asynchronous code and not needing to think about things like threads and the overall sort of concurrency of the application becomes a lot simpler for me, because I don't have to think about where I want to insert a thread to do something like this, or how long that thread might live, or how I'm going to communicate with it. I just write things in terms of async functions, which are really just spitting out futures. I'm just writing code in terms of futures, and Tokyo deals with, all the concurrency for me, which is really awesome. So we're going to do that today. In particular, we're going to use my personal favorite web framework, which is called Rocket. I mentioned on Monday that Rocket some have touted Rocket as a little problematic, in that it's had, periods of, say, 5 or 6 months where it hasn't really made progress, because it's sort of just like one person's web framework that a lot of people quite like and a lot of people sort of want to contribute to. But at the end of the day, this is still just, Sergio's web framework. But, regardless of that, whether it's suitable for your production use case is your own question to figure out. But I really like it because it makes writing web services in Rust particularly easy on the developer end. And it makes really nice use of a lot of cool Rust features that we've learned throughout the term. So it's a nice sort of wrapping things, bringing everything together kind of thing. Cool. So we're going to look at that. There is one last thing I wanted to finish off with the future trait that we didn't get time for on Monday, which is waking, right? This context thing I mentioned when you want to poll the future, hey, do more work, do a little bit more work. You need to pass it a context. This context is a type which currently just holds a waker. So then when we asked, why doesn't this just take a waker if a context is just holds a waker. They might want to add more types in future as the answer. Right now, all they've, found is worth including in the context is a waker, but, in future, they may decide that actually we'd like to have 3 different things in here or something like that. So that's important. But right now, right, it just holds a waker, and right now we have done nothing with that waker. If you recall, we implemented our own waker, which just does nothing, and then we literally just like always ignored the context whenever we were using it. Like this just ends up getting used nowhere. Okay, so this is an interesting, and there was another question in the last lecture, which was really, it was a great question that really gets to the bottom of why we care about wakers, which was this. Someone asked something to the effect of, isn't it a little dodgy that we're just sort of in the, like, getting the websites using futures function that we wrote here, we just sit in a loop constantly polling all the futures, all the tasks, all the futures. We go poll it. Like for each of the websites, maybe I think there's 3 of them we're looking at here. We go poll, and then say like Python comes back first, and then poll. Then C++ comes back and it just goes poll on Rust until eventually, okay, I'm done. Now it is important that we poll the future, because again, the future can only make progress. Well, the future can only start work on new progress, is maybe a way of saying it, when you poll it. So in our futures case, there was 3 sort of states that it goes through. It starts off in the initial state, then you poll it and it sends the request. That request will take some time, and then once that request has come back, the next time you poll it, it'll give you back the answer and the request will be done. And so, right, we can only transition between these states here, each time poll is called. So we would never get the result back if we weren't polling the future, but polling it probably millions of times before it goes, hey, it's done, is probably a little excessive, I would say. In fact, we should be fine just to poll it twice, right? We create the future in the initial state, and then we say poll. That should send the request off, and then we really only want to poll the future again once this web request is done. That would be ideal. That's like the perfect case scenario. We can't do this. We can't use this future with less than 2 polls. But we should be able to do it with exactly 2. And obviously, if you can do it with 2, you can do it with 3, you can do it with 4, you can do it with 5, and so on. And you can do it with what we've currently got, which is probably millions, right? So we'd like to be able to do this with 2 polls. And again, Rust is a language that cares a lot about, doing things the right way and performance, and not just sort of, spinning in a loop like that. And so that's what this idea of a waker is about. When you create a context, when you get past a context, no, this is not working. Let me grab this. Here we go. Push this. Oops. And grab that. Decide later. So, when the future is polled, we saw it takes a pin of self, whatever it is, pin of ref mute self, I think. Something like that. Whatever, it doesn't really matter. And it takes this context. Context is an @mute context of tick underscore, whatever. This context came from somewhere, right? In order to call poll on the function, someone needed to have created this context. And it allows us access into a waker. So cx, we saw here cx dot waker lets us access the waker. Right, oh, thank you. So cx dot waker is really like all it's useful for. It gives us that waker, or a borrow of it, whatever, it doesn't really matter. And this waker has this interesting function here, wake by ref. Wake up the task associated with this waker, right? Or we could do dot clone and wake. These are whatever. For our purposes, they're basically doing the same thing. So on this value here, we can call dot wake, essentially. Oops, dot wake. And what this function here does for us is it tells, so there might be some kind of executor all the way up here. This is basically the program that implements the event loop of our Rust async code. So this is basically an executor, is something that you sort of spit futures into, right? Future goes in and it sort of deals with processing the futures until the results come back out, right? At a sort of high level. An executor is something that should get thrown futures, and it knows how to efficiently communicate with futures so as to eventually get their results out. And the idea here is that if the future calls .wake, it's essentially telling the executor, "Hey, I'm ready to be polled again." And the executor will go and poll it, and it'll move on to the next step. Maybe it's done now, and it goes, "Here's the result," or it does some other work, and then eventually calls .wake again, and then the executor goes, "Great, I'll poll you again," and you sort of like get this event loop, right? This loop of making progress over time. And the trick here is you might go, well, if we're polling the future, right? We call poll, and the future mustn't block, right? Calling poll shouldn't block the current thread. It should kick off a task and then return back very quickly. And in doing that, it should make progress on the task in the background, kind of thing. So then how does the poll, how does polling this future that can't block and, has to do stuff in the background, end up calling wake? If it hasn't got access, well, it could just make a thread, like what we've done here, right? We could just say spawn a thread, send the response, and then say context.waker.wake, like this. And it's pissed off because context might not exist anymore. Yeah, that's context isn't cloned, but wake is. So we would do something like let waker is context.waker.clone. And then this is waker. Like that. Excuse me. Now it's sort of signaling, hey, the response has come back. I'm ready to be polled again. And in implementing our waker, we wouldn't just do this horrible do nothing, right? This function would end up getting called, and that'd tell us, hey, it's time to poll this future again. And again, this is what an executor, a runtime like Tokyo, would end up implementing under the hood. Now the trick here is, again, you might just go this, all roads seem to lead back to threads here, right? Why are we bothering to do all this stuff with future if it seems to always end up getting implemented by spawning a thread, doing some stuff, and then saying, hey, I'm ready for more progress. This just seems like threads with extra steps. Now there's a couple answers to this. Answer one is, even if that is the case, even if all roads do lead to threads, there is still utility in this future type, and it gives us this abstraction over the idea of a concurrent task, which we talked a little bit about on Monday's lecture. But the other trick here, this is sort of the other really neat thing about this whole system, is that Tokyo, for example, basically re-implements a big chunk of the standard library. Any bit of the standard library that's reliant on things like I/O that might take time, might take considerable time to actually to complete say, reading from this file system, or things like sleeping a thread, that kind of thing, like thread-related operations, Tokio essentially re-implements. So if we go to Tokio FS and we go to the standard libraries FS module, we're over here. These will end up looking very similar. The color schemes are a little different, which makes it maybe a little hard to see, but like canonicalize, copy, creator, role, hard link, metadata. Like, they implement the same operations over in Tokio. And if we say look at read, for example, Tokio has read impl as ref path goes to result vecu8, read as ref path goes to result vecu8, but the standard library just implements finRead, whereas Tokio implements async finRead, right? So they implement like a future version of this, a version of read that is asynchronous. And then once again, the big trick here is that Tokio, as part of its runtime, knows very like performantly how to deal with asynchronously reading from a file. So using system calls like epoll, Tokio can essentially say, like, I am writing my async code, and I have in my future, like this future that might be polled or whatever, the future I'm dealing with might be, say, read. I read some stuff and I say .await to say wait for this future to complete. In this read future, which will have its function poll and that kind of thing, Tokio will essentially do something like this. So read will say, I want to read from this file over here. Tokio is this big beast on the right here. This is Tokio over here. And, you know, there's a lot of moving parts in Tokio, and maybe like, you know, here's my representation of all the bits and pieces of Tokio. And, you know, over here we have like the file IO section of Tokio. And so I want to read from this file, something like that. It goes and sticks it over here. And then, you know, Tokio is going and doing a lot of work, sort of, you know, almost like all the time. It's generally always doing a lot of work. And just every now and then it'll go like check on the file. Right, and this is probably, this can very easily be on one thread as well. Tokio lets you configure to say, hey, I'd like to run this on every core if you really want. But all this stuff can just happen on literally one thread if that's what you're looking for. And it'll look around and go, you know, check on this file, or have I been woken up to go check on this file or that file, that kind of thing. And when it says, oh, right, this file has completed, it's able to go and wake up that future and continue making progress on it, and, you know, jump over to your async function, really wake up your async function in a certain sense. Your async function is doing some stuff, and, you know, the read completes and it goes, great, go wake up, this thing is ready for you now. It'll poll your future that gets generated out of your async function, and it continues on and does some cool stuff. So this is all to say, like, this is pretty heavily advanced stuff, and it's a little ambitious trying to attempt to explain this all in a rather quick manner. But so let me give you like the cliff notes here, the big ideas that I think are worth taking away from this. So we talked about before, future is nice abstraction over a concurrent operation. Futures will only like make enough progress to move on to the next step that might take time to complete, kind of thing. When you actually poll them, we don't want to just say poll in an infinite loop, because that will very easily stall performance, and it just ends up meaning you're blocking on them anyway. So instead, futures have a way to signal to, say, like their executor or the system around them that, hey, I'm ready to be polled again. I'm ready to make some more progress. Or waking might even be saying, I'm finished and I'm ready to spit out a result. So at the absolute baseline here, you can very easily implement, hey, wake me up, just using a thread. If your task is just spinning up the thread, do some stuff, and then say, hey, I've got the result and I'm ready to be woken up, then that will work. That should work just fine for you. But and like you should basically be no worse off than if you had have written this all by hand as well, because like if you're doing this with threads yourselves, you're either going to be like waiting for this thread in a loop and going, hey, I'm waiting for this thread to be finished so I can get this result, or you're going to be trying to get that thread to wake you up when it's ready, maybe by sending it through a channel or something like that, saying, hey, I'm ready with that information now, like you wanted, that kind of thing. So if you're just planning on using threads anyway, you shouldn't really be worse off using futures. It should adapt quite well. But the big trick here is that if you're making a large system, right, a large runtime like Tokyo, then they can really take all these different kinds of tasks, right? Whether that's reading from a file, whether that's making a network request, whether that's talking to a different process on the system, whether that's a sleep or a timeout or that kind of thing. These can all be grouped into the same interface of a future, and Tokyo can really efficiently multiplex all these different ideas with a very small amount of actual threads and a very small amount of actual data that's kicking around. So if we can vaguely understand how this idea of like wakers, saying that this thing's ready, and futures can work quite nicely in the context of a slightly monolithic runtime, a runtime that knows how to do a lot of stuff, right? Knows how to do hopefully like almost all the stuff that you're looking to do, then overall you can get a really nice, coherent, high-performance system that is hopefully like, relatively pleasing to use as well as a developer. If we can agree on the premise of this, then we're ready to move on and start writing that code ourselves, I'd say. There was one other thing that I wanted to quickly mention, which was, it was something about Tokyo. Yeah, maybe I've immediately forgotten. But yeah, regardless, Tokyo is pretty cool. So yeah, it's sort of like it's cool with Rust. That's what I was gonna say. Yes, I remember now. So if you're happy with that, then that's great news. If you would like, if you sort of know a little bit about language runtimes and you've heard things about concurrency, and you want sort of a quick take on a few things, this is potentially better than just always spawning operating system threads like we've gotten you to do in things like your assignment and such, because you can achieve, when you're IO bound, right? Not when you're performing very CPU intensive work. When you're IO bound, you can get the same like sort of raw performance, like the speed and concurrent activity, as if you had, dozens and dozens of actual threads with just say one or two operating system threads, or a very small handful of them. And operating system threads generally take up a reasonable amount of resources, and they can be quite expensive to switch between, to context switch across different OS threads. This is potentially better than green threads, if you've heard of that, which is the M2N threading model, where you have in the language lots of threads, lots of sort of fake threads multiplexed over a smaller amount of actual operating system threads. Java, I believe, Java almost, not necessarily, but Java is relatively prominent in this case, I believe, with a green threading runtime. And the take here is that green threads, especially when you're working on, you're not working like in a language VM, like a virtual machine that Java runs on, it can be really tricky to estimate requirements correctly, and you can basically end up using use up a lot of memory, especially when green threads are kind of encouraging your developers to like go crazy with them, spawn thousands of them if they need to. And if each thread ends up, taking up a lot of memory, then that could be quite, dangerous. If you have Go used to have this model where they would only, and Go is basically green threads as well. They call them Go routines, and they've got some, some nice syntax for them and some nice features, but they end up essentially just working as basically like green threads at a low enough level, is my understanding. They had these interesting techniques where to combat that idea of green threads potentially using a lot of memory per green thread, what they would do is they'd start off the thread really small, and then as you sort of use more data, it would dynamically grow your stack over time. And what I believe what they found, and Rust used to do this as well. Before Rust was released, Rust had green threads, believe it or not. They tore green threads out before the language actually was released as 1.0 in 2015. And what both of them found, if I recall correctly, is that there was these interesting thrashing issues, where if you had this loop, right here, which uses some more data right there, you'd sort of find that you'd use the data and it needs to expand your stack. Then the loop iteration finishes and you need to go back and it frees up that stack. Then you enter the loop again and it uses more, and you get this like allocate, deallocate, allocate, deallocate, allocate, deallocate that just like absolutely tanks performance. And Rust stopped doing that and then destroyed the green thread runtime. I believe Go routines also stopped doing that because of similar issues. So it's kind of an interesting balance. And if you're looking for the technical terminology to keep looking into this kind of stuff, the technical terminology would be stackless coroutines is what that's not how you spell coroutines. Coroutines. Green threads is generally considered to be stackful, which just means that they have like that managed stack that I was drawing, kind of like this. And this also is vaguely relevant to fibers as well, is another terminology that appears. And then another very common technique is just straight up OS threads, which is what you see in things like C and somewhat largely C++ as well, I'd say. C++ does have some green thread runtimes that you can use. I'm sure you can probably get away with stackless coroutines in C++ as well, but I have literally zero experience in that. But the general offering is usually just OS threads, is my understanding, but I could be proven wrong. And green threads versus OS threads, at the end of the day, you need some OS threads to do your work on. The big deal here is in like C and C++, you say spawn me a thread, you say spawn and it literally spawns an OS thread. In a green thread language like say Java, like say Go, you say spawn a thread and it creates sort of like an object in the language, right? So this is, imagine here is like the language and here is the OS. It spawns an object in the language, and then they have, as part of their runtime, as part of the code that sort of helps execute your program, they multiplex the language threads onto, single OS threads. So this might be, you might end up with a small amount of language threads to OS threads. You might end up with all the language threads are only multiplexed across a single OS thread, right? Like every single thread is just pointing at one OS thread. That's sort of down to the language. I think Java for a long time, I think, and this is a think, so not a quote me on this kind of thing. I think Java for a while only would multiplex over one OS thread. But please tell me if I'm wrong about that. I'm not sure I have no idea if that's still the case. I think when Java released, that might have been the case. So green threads kind of needs a VM. Yeah, green threads, you generally need some kind of runtime to make them work. At least to make them work well from what I've seen. And Rust did used to have a runtime before the language was actually released, when it was still being developed. And then they decided that wasn't really in line with what they wanted for the language, and so they tore out the runtime. So now Rust doesn't have a runtime, in quotes. it's sort of like people generally consider languages like C, C++, and Rust don't have a runtime, whereas say Go or Java and that kind of stuff do have a runtime. If you say that Go has a, sorry, if you want to say that Rust has a runtime, then you're sort of opting in to say that C and C++ have a runtime as well. Just they're generally very, very small, lightweight runtimes. So it's, as long as you're consistent about it, I'm happy. But I don't think there'd be too much of an argument in saying that, say, Rust has a runtime but C++ doesn't, or vice versa. They have, and even C, they just have very, very small, lightweight runtimes generally. How do you call syscalls in Rust? Is that through FFI as well? I assume Tokyo will need to do that in their implementations. Generally, it's like it is through syscalls eventually. It is through syscalls eventually. Usually, system calls are a little unstable, and system calls are a little unstable and not that great to rely upon. So people generally use libc, like the C standard library, as kind of like their operating system interface. In that, not necessarily things like fgets or that kind of thing, but the C standard library offers like a syscall-y interface in things like read, which is basically, this is just going to end up being an interface into the read system call on whatever system you are. So yeah, Tokyo, whether it ends up using the standard library for some of these things, it might be able to. Whether it's not able to use the standard library for some things, it has to go down to the like system call level. I'm not 100% sure, but I could honestly see it being either way. It does depend on libc for whatever that accounts for. They do depend on libc, so I imagine they probably need to use the C standard library for something. Microsoft calls their C library the Universal C Runtime, UCRT. Yeah, see, that sounds about right. I think the Linux or the Unix equivalent is CRT0. CRT0, the C runtime. Yeah, there you go. CRT0 is if you're interested in that. This is the like C runtime, if you want to call it a runtime. Okay, can we use Tokyo on assignment 2? Yeah, I mean, if you want. This is something interesting. It's Wednesday, and it's due on Friday. Something interesting I mentioned to Tom as like an aside is assignment 2. If I was writing assignment, if I was, say, like working a software engineering job and someone said, hey, we really need you to whip up an IRC server in Rust, I wouldn't be writing threads myself. I would be using Tokyo. I would be writing async Rust. Because I would find it to be easier, probably simpler to scale. It's just sort of like the more correct tool for the job, which is interesting because we're getting you to do it with threads. We're not going to stop anyone from using async Rust to implement assignment 2. And if you want to take on that yourself, then it's you are free to do that, but we won't support it, is what I will say. In that if you have problems go wrong for you and I need help debugging this future crazy async code, we're going to go, sorry, you did this to yourself. We're going to suggest going back to using threads. But you are allowed to answer the question. You're allowed to implement it however you want, as long as it's not just implementing it without concurrency. Like, you need to have functioning concurrency, but how you do that is up to you. Can I give a high-level explanation of how ePOL works and how something like Tokyo would use it? I can give like a 3-minute explanation, and that's what I'll offer during the lecture. Partially because, time constraint, but also partially because I'm not an operating systems expert. And I only know it at a relatively high level anyway, and so I don't generally like explaining things at the exact level that I know them at, because that's when you're the most likely to dip into mistakes and give bad info. So I'll give you a very quick, very high level overview. I believe the way ePOL works is that, let's say I tell Tokyo, Tokyo, I'd like you to open, this thing, open this file. I'd like you to open this file. I'd like to connect to this socket, like open a network connection, blah, blah, blah. And the operating system goes, sure, this is file descriptor 1, that's file descriptor 2, that's file descriptor 3. Okay, these file descriptors make no sense because stood out, but whatever. And then you can say something along the lines of ePOL on, 1, 2, and 3, and I'm waiting to, I'm trying to read from these things here. And this is in the context of some thread, blah, blah, blah. And at this point, you get put to sleep. Your thread goes to sleep, and then the operating system will come and wake you back up once like the read event on one of these 3 things here is ready, and it'll say, hey, it'll like return back from ePOL, hey, we're ready to like read for 1 and 3. Like the data has arrived for these. And then you go and read that data, and you'll say like ePOL on, like I'm just waiting to read from 2 or something like that. And so the trick here is we can now be concurrent across, 1, 2, 3, 1,000, 10,000, a million files, waiting to do sort of concurrent operations on them with only like one like IO thread that just gets put to sleep while it's waiting for some kind of operation. That's sort of the very high level idea of it. So you'd probably I believe Tokyo does have clever ways that are probably more advanced than what I'm able to explain right now, of running with just one thread. But the easiest way I see of doing this is that you have Tokyo's main thread, and then it has like an IO thread that does like the waiting and the polling, and then updates things like that. And so Tokyo will just like send stuff over to this IO thread, which will wait on it and then notify it when the stuff has come back, that kind of thing. But Tokyo does manage to do so across a single thread. It might be some more advanced trickery than I'm able to explain right now. But that's sort of high level how ePOL roughly works, I think. All right. So what was this? Oh, this is our future code. Cool. Oh, like 18. Oh no. Oh, so sad. It only works when you're I-bound. Yes, right. The thread doesn't do much computation. So Tokyo is not a great runtime, a great service for doing like CPU bound work, because it tries to use very few operating system threads. Again, usually my understanding is it's usually 1 or a very small handful of actual operating system threads. And in order to do like, CPU bound work quickly, in order to achieve parallelism, which is what you're looking for when you're CPU bound as opposed to just concurrency. In order to achieve parallelism, you really do need access to those operating system threads. OS threads are how the OS provides the opportunity for parallelism at all. And in fact, it says here, CPU bound tasks, Tokyo is able to concurrently run many tasks on a few threads by swapping in and out of threads. However, this kind of swapping only happens at await points, blah, blah, blah. So they say if you do have a blocking task that's going to like do a lot of CPU time, then use this function here, which will actually go spawn an OS thread to do the work. And you can like await for that to finish. But what it's saying is, if like your overall project is CPU bound, like if you have a lot of CPU bound stuff, not just like this one thing that you want to, integrate with the rest of your like quite IO focused code base. If you have a lot of that, you might want to consider using Rayon. Yay, we know this one too, which is that data parallelism library that helps us write very parallel code. And then there's tricks to integrate Rayon with Tokyo as well, where Rayon pulls in a whole bunch of OS threads to do that CPU bound work, and then Tokyo only needs, the 1 or 2 threads for itself. And then you'd probably just communicate over a Tokyo channel to say like, hey, the Rayon thread finished figuring the Rayon thread pool really that's working on lots of OS threads has finished doing its work. Here's the result, and that passes it back over to your IO Tokyo code. So yes, Tokyo is very much an IO based executor runtime. Yeah. Cool. Any other questions for now? In fact, let's take any questions until we have and until you're out of questions, and then we'll take a break. And then when we come back from the break, we'll write some fun website code. So any more questions before we take a quick break? A question I have that I'm gonna plug in here before we go to the break is my experience. My experience is a cool thing. Please fill out my experience. It's sort of extra important because it's the first time we're running the course. Is this dangerous to open up in front of everyone? I'll put it on that monitor for now. Yeah, there it is. Yeah. So it's extra important for us. If you could find, in fact, let's take an extra long break. Let's take a break until 7, right? That's the longest break we've ever had. Let's take a break until then. So you have some time to fill out my experience as well. If you're able to do that, that would be very, very nice. We've got 10% completion, which is honestly more than I was expecting at this point, if I'm 100% honest. But we're gonna be hounding on you at the workshop as well, probably to get some people to fill it out. But yeah, if you can find a little bit of time to fill it out during the break now, that would be excellent. Otherwise, we'll come back at 7. So Rayon is sort of like Rust MapReduce. Yeah, Rayon's sort of like MapReduce on a single computer. Like MapReduce, you can imagine as splitting up a bunch of work, like a bunch of tasks onto many computers and then reducing them back into one like result. Rayon is that same idea, but in the context of a single computer where it's splitting up the tasks into many threads. And yeah, that's a perfectly reasonable way to think about it for sure. Incentive, I haven't thought of an incentive. If you want to suggest incentives, then you're more than free to. But I haven't got anything in my head right now. All right, let's take the break. Fill out my experience during the break, please. And we'll see you for our last hurrah, last little fun thing at 7. And that is 7 o'clock. We are back. Did we fill out my experience? Did we do it? Or are we like, oh, they're going to make us do it at the workshop anyway. I'm just going to do it then. Did anyone actually fill it out? D Wang, well, yep. I don't know. I guess that's the problem of asking two yes or no questions right after one another, is that I don't know which one's that. Yes, that's yes too. Oh, I can see it went up a little bit. Hooray! Oh, Dong already filled it out. That's very nice of you. I can see the response rate here has gone up a little bit. Thank you. But yes, I'm sorry to say we are going to definitely keep bugging you at the workshops. All right. Nice. So, yes, now we get to do the fun thing. Reserving judgment until the end of the lecture. Yeah, okay, that's fair enough. Yep. Okay. Let's go. 2511 gives 1% bonus to everyone if the response rate reaches 85%. Wow, that's a high bar. Maybe I should get Tom to write a forum post about. Tom has a very convincing argument that he doesn't think it's I'm going to be very picky with what I say here. It doesn't think it's necessarily the best idea to offer bonus marks based on like sort of course-wide activity. If he's comfortable sharing his I think his relatively convincing arguments, I might get him to write that on the forum. But maybe we might have to come up with something. I guess we'll see how the workshops go. All right. So Rocket, I love Rocket. Yes. So Rocket has a website, rocket.rs. It's like a nice, pretty 2020s website, as you can see. And I think it's really nice. So if you've used something like Flask, Flask is the one that really comes to mind here, then honestly, it kind of like gives that impression of Flask for Rust. It's, it's probably easily a few million times faster, but that's maybe another conversation. But it does make writing, websites, web backends, that kind of thing, quite simple, which is really nice. So Rocket is what I've got here, and we're gonna grab Rocket, the release candidate 2 for the 0.5 release, which has been in candidacy for a while, as we've sort of seen before. But Rocket is pretty cool. Rocket uses Tokyo. So in using Rocket, Rocket is essentially backed by Tokyo. We should see in its dependencies that it pulls in Tokyo here. And so it's sort of it's like it's a full web framework. And so there are other web frameworks like Warp, Hyper, Axum. What am I thinking of here? I'm thinking of Warp. Yes, which is like Warp is a web framework. Well, it's more of like a website building library as opposed to like a full-on framework, I'd maybe argue. And so you would use Tokyo, and with Tokyo you would run Warp. So see here they go Tokyo main, async function main, that kind of thing, and then call like Warp functions. So that's certainly an option. But Rocket sort of aims to be like a full-on framework that does a lot of this work for you. But again, at the end of the day, we will be using Tokyo. So Rocket suggests that we put this launch annotation on our main code here, which I'll probably need to import. And now that lets us declare this is async function main, async function Rocket, or function Rocket rather. Okay, cool. They probably define their own async function main that they would like to use. That's why we can't use main. So function, what do they call it? Launch? I think you can call it whatever you want, really. Maybe not. Oh, launch doesn't really make much sense, does it? What are you upset about? It must return a value, right? Yep. Sure. Let it figure it out. It seems it's fine, and it just needs to. Let's just copy the code in, rather than dealing with every little error as we go, and forget about mounting for now. All right, cool. And so, as such, we've now got code to spin up a website. If I go to, yep, I'm already here, cargo run. I'm gonna have to build all of Tokyo. It's nice because the room was getting a little cold. So this is gonna help warm things up a little bit. Great, we've got a website. There it is. Rocket is launched from 127.0.0.1.8000. So 127.0.0.1.8000. Wow, that's so weird. It looks like the course infrastructure. I wonder why that is. 404 not found rocket. Great. So that seems good. They probably have that like an actual hello world example, which we can do here. So in Rocket, we can define a route. Get, when we just get the root of the website, it will give a string back, hello world. And so I can say mount on slash the hello route, like this. Restart the website. And now it says hello world. Yay. We're probably going to be using or making pretty, heavy use of a tool called curl to do a lot of talking to the website. And it's just going to look something like this. It'll just be like curl 127.0.0.1.8000. And you end up seeing just what a web browser would see as well. It just doesn't render the HTML necessarily. Cool. So curl lets us make that web request and see what it responds with. So like generally not too bad to use, I would say. All right. So our idea is that we would like to make a bit of a like paste bin service. Serbia must be making bank from all these .rs. Yeah. Welcome to CS6991 paste. Right. Welcome to CS6991. I think I can even do cargo watch dash X run. I mean, I guess that's probably what cargo watch will just do. Oh no, it just builds it, I guess. Dash X run. This is cargo watch is a nice tool because when I save the file, it'll just rebuild it and restart the website automatically for me. So now it says welcome to CS6991 paste. Oh, no RS pun. CS6991 pasters. Great. It's sorted. We figured it out. CS6991 pasters. Because we are now the pasters who are pasting things into the website. All right. So we'd probably like to have a way to create a paste on the website, right? And just to be clear, in case someone hasn't seen stuff like this, there's tools like Pastebin, right? Where I can say, I can make a new paste that just says, hello from CS6991. And like, okay, it has a whole bunch of settings, but we don't really need those things. Just create the paste. And then I will get this permanent URL here where I can give it to anyone and they'll see this paste here. We're making a very like bare bones version of this. So for example, if I paste this Pastebin URL in the chat, which I did through OBS and actually seems to have worked. Good job, OBS. You'll be able to click on that and see the paste that I created. So it's kind of handy if you need to share a snippet of text, an error message, some like log files, it's pretty handy for that kind of stuff. And we're making our own little paste bin now. So we'd like to be able to like create a new paste. It's something users probably want to do, and probably a way to like retrieve someone else's paste. Right, that's what we're looking for here. Okay, so notice that also when I made this paste, obviously, it stored the text that I wrote here, and it also generated this sequence of characters, like a short URL for storing the paste. we could, we could use whatever we like want here. We could generate some random text. A pretty easy solution here. It'll definitely be a lot longer than the paste that's written here. But we could use something like a UUID comes to mind. A UUID is, well, in particular v4 UUID is a sort of convenient way of just generating a random sequence of bytes that just gets stored as a string like this. And we could just generate a random UUID and say like, pasters / this thing here, and that'll refer to our paste. It's certainly overkill, but UUIDs make this easy because the likelihood of generating two like random UIDs that happen to collide with each other is unbelievably unlikely. So like the uniqueness property is not strictly guaranteed. However, for all practical purposes, it can be assumed that an unintentional collision is extremely unlikely. Like, I wonder if we can quickly Google UID v4 collision probability. Yeah. I love Google. Google's like AI for finding the answer. Okay, Quora seems to have found a nice way to visualize this. They say if every person on the planet generates a new UID for every second a collision to occur after 10 years, okay, it's actually slightly more likely than I thought. But that's, still, yeah, that's for our purposes. I was looking at this one. If you generate 1 billion, UID v4s every second for 85 years, there's a 50% chance of a duplicate pair in any of those, is apparently what source dude trust me. So yeah, anyway, it's basically 0 for our intents and purposes. So we're gonna just use we'll use this crate. In fact, let's use cargo add UID. But I want v4 UIDs. Dash features v4. Great. And we'll just use UIDs to represent this this paste, the paste sort of ID. Okay, so Rocket has a pretty neat idea. Of these types of these sort of like guard types. That's not that helpful for what I wanted. Rocket guard. Yeah, there's tons of different guards, but I was hoping that they would tell us, like, talk about guards more generally. So in particular, well, okay, no, this is what I want. Rocket works with this idea of request guards, which is pretty cool. It makes nice use of like Rust's sort of, things that the Rust language allows you to do, allows you to help sort of create safe programs, in that I can create some type of data. In fact, maybe this is just better shown by example. There's actually a relatively cool example of this in the course infra. I just got to be sort of somewhat careful. I got to be a little bit careful. Here we go. Get rid of this. All right. Let me just get rid of that as well. Okay, this should be fine. So for example, we like to tell whether someone is a tutor or not when they're on the course website. I don't know if any students have noticed this, but like if I'm, say, in the lectures page or whatever, I blame CSE. There we go. If I'm on the lectures page or whatever, you can actually see there's this little login as tutor button down here, which lets us access resources before they're released and that kind of thing. And so how are we going to tell if someone is actually a tutor or not? And so the idea is that we made this struct tutor that takes no parameters, right? Like this struct tutor doesn't actually hold any data. It's a 0 size type. But the idea is, and this hasn't been implemented super that well. Yeah, it hasn't really been done great necessarily because I actually would have preferred if there was something in here that's just like private is unit, that kind of thing. But essentially the idea is that the way you acquire like a tutor struct is specifically written as a guard on a request that basically goes check like if someone has a cookie, and this is using something called JSON Web Tokens as well, JWT's JOTs, to make sure that no one can sort of cheat the system or whatever. But like basically check in the request to the website if the person actually is a tutor based on their cookies. And if they are, then we create this struct for them to use. And if they are not, then we say that it's unauthorized. And then when we're creating like a request, like when we're creating an endpoint like hello, I could just throw in like tutor like this, if there was, assuming there's a struct tutor in here. And what Rocket will do is when this function hello is getting called, it will like go and run this code over here, check if they're actually a tutor, and then see if they can get the value to give to me. Otherwise, if they can't get that tutor value, we know that this function could necessarily never be called, because Rust doesn't just let you generate types like willy-nilly. You need to actually, it needs to be instantiated properly somewhere. And that's sort of the job of this block of code here. It'll only ever give out the tutor thing if they have the cookie and it's valid and they are a tutor for the course, that kind of thing. And so it's a nice trick to leverage Rust type system, and we can do a similar thing as well ourselves. So we could say, for example, if we're looking to create a paste or something like that, we might like to, let's say we're retrieving a paste. We're going to want to store our paste somewhere. So I'm going to make a folder here called pastes, which actually stores people's data. If we're retrieving a paste and we say like, what's the paste you'd like? And imagine that's some kind of string. And then we say, we'd like to say something like, file open, /pastes/ their paste, that kind of thing. You could imagine this could be quite dangerous, because what if the paste that the user asks for is not something like, is not something necessarily like this, right? They might not just ask for a paste like this, but they might ask for a paste that's like, right? They could ask for this paste. And then they go, okay, the code goes, sure, I'll throw that right in there. And then like it goes, great, I've opened the file, here's the contents, and like the secret exam answers have all been leaked to everyone, right? So we could make some sort of data guard on Rocket saying that, hey, we want to like make some sort of type here. Maybe it's like a paste ID. And as part of this type, this paste ID type, which is really probably just going to be like a string at the end of the day, as part of like creating this, we'll validate that it's actually like a real UUID and they're not up to any tricks like this. And that way, again, we're leveraging Rust, we're leveraging what Rocket gives us in order to make a very sort of safe, to make a safe interface for us. So paste ID. So this is going to represent some kind of base. Actually, string is probably not really what we want. In particular, probably want a UUID, right? Hello, use UUID. Oh, UUID, of course. Like that. So if we'd like to do make a new one, we might like say impl paste ID pub for new random, which gives us a paste ID. And this is just going to construct a new self with UUID new v4, like that. And so now we have a way to create a paste ID, and then we could say like pubfin like path to file, say, which is going to give us a like the sort of actual location of where the file should be, and that's going to be like /pastes essentially. Path, let's say path from /pastes slash. Actually, I might not need the join. No, sorry, I might not need the slash here rather. /join on the UUID is what I was looking for here. self.0.toString maybe. And then path. Fine, whatever. We'll just make a path buff. Path buff from this dot join that. I guess we could even do path buff from dot join on the pastes folder, and then we're looking for a file in there that's got the same name as the UID here. So that's pretty convenient for us now. All right. Cool. So we've got this nice paste ID type. And now we want some routes to be able to create a paste itself and to be able to retrieve a paste. And so let's start off with creating a paste, because it's going to be hard to retrieve a paste until we've created it. I'm going to make a new post route called /create. I think seems like a potentially good idea. And then we're going to want to take the contents of, like, if we go back to the example that I was doing here, I needed to tell them the contents of the paste I'd like to make. And so, like, how are we going to take that in? Is that going to be a string? Is that going to be something like that? Sure, probably. But there's also another potential issue here, which is, what if someone tried to make a paste that was like absurdly large? I mean, I wonder. Oh, okay, cool. I wonder if Pastebin has a like a max size. How many pastes can I create? What is the maximum paste size? 512 kilobytes. Right. What if I just tried to give them like 100 terabytes of data that I'd like to store in a paste? That could really ruin my computer or my server. And so Rocket naturally has some nice types to help us deal with this. In particular, I'm thinking of data here, which is a type representing the body data of a request. And data itself here is pretty nice. It lets us just sort of see these things as bytes, limited to a certain limit here. So we can say let's stream as data.open 2 megabytes. Probably we'll just stick with what Pastebin says here, which was what was that, 512 kilobytes. Seems more than reasonable for what we're making. That'll give us a data stream, and it seems that we can write it into a string, we can write it into a vec, we can write into, like, all kinds of different things. Even a file, that's not a bad idea. Yeah, we could write it stream into a file straight away. So that's pretty cool. Interesting. All right, so let's go create a paste, and we're going to use this data thing here with a certain limit. Have they got a little example? It seems they do. They say data guard can be any type that implements from data, and data, this type here, does implement from data as well. So we could even make our own implementation of this, but I think theirs seems fine for us. So we need to say that there's going to be a data parameter here, which I'm going to call the paste. Then we'll say paste here, which lines up with that, is a data, rocket data, like that. And then we're going to say paste.open with a certain limit. Let's look at this byte unit thing here. It seems we can say 1.gigabytes or 256 kilobytes. Oh no, we wanted 512, didn't we? So I guess 512 kilobytes, like that. And this gives us back a data stream. Awesome. Data stream. and we'd like to stream this into a file. Stream to stream precise to checked with existing file unchecked. Stream to a helper method to write the body to an async write type, returns n, which indicates how many bytes were written. An additional read from self may be required to check if all of the stream has been read. Okay. No end of stream check is conducted, and thus read write completeness is unknown. Okay, so this seems like the easier one for us. This is async, meaning it returns a future for us, so we're gonna have to think about that as well. So we're gonna stream this into some kind of file. Okay, cool. So I've mentioned that we're working within Tokyo. Oh wow, the lighting has really gone downhill since I last looked up. That's a little better. Oh, I also just forgot to turn the room lights on entirely. Okay, we get a slightly spooky last lecture. Okay, cool. And so we'd like to create a new file. So we're going to need a new paste ID. So let paste ID equals paste ID new random. That's going to be our paste. Then we'd like to turn that into, that's not really, wait, path to file. That's a horrible name. It should be paste to path is what I really want. So then we say paste ID dot paste to path. That's going to be the path to the file we'd like to make. And then let file is file. And note, we're not using std.fs file. We're using, well, Rocket Tokyo.fs. Rocket seems to re-export Tokyo as well. So we don't need to import Tokyo ourselves. We could really do it either way here. But we'd like to create a file with that path. And this gives us a future of like result of file. So usually we'd say like file.create and then something like expect here saying the path should be fine to create a new file in. But this is not going to work. We'll leave this for later. This is not going to work. It says no method named expect because it's an impl future. Fortunately, the compiler is, again, as it sometimes is quite smart, and it says, hey, you might need to await on this future, right? You might need to await on this future. So essentially what we're saying is we can't really progress until this future is completed. So we'd actually like to say that we would like to wait for this file creation to finish before you should come back to us and keep doing what we'd like to do. But then we get another problem. Await is only allowed inside async functions and blocks. So in order to wait on someone else's, async function, right? Async function here, or in other words, await on a future, we need ourselves to be async, right? And then this, okay, fine. It just wants me to say that there's a lifetime there. And now we've essentially like generated our future ourselves in writing async function and await. What the compiler is going to spit out is this create paste function is either going to be init with like paste, init with paste is some data, and paste ID is some paste ID, and path is some path buff, and file is not going to be a file yet, right? So it's going to be this, or it's going to be like awaiting the file, like awaiting file create, and it's going to store like all this stuff again. And also here is going to be like the future that we're waiting on. This syntax is not going to work, but like you can imagine something roughly like this. We're waiting on this, and then like at this point there's going to be then like finished afterwards here. And then it'll also generate us like impl future for create paste, where the output is, what does our function return? At this point it returns nothing. It'll return something when we change it later. And it's going to have poll with blah, 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 and, work through these states. So like a lot of stuff actually happens in just like a little bit of sugar here, async and await. But Rust allows us to both have those low level details when we'd like them, but also just have a nicer developer experience when that's what we're looking for as well. So in this way, we now have a file. We've created a file concurrently, right? In a concurrent manner. If this file creation takes a long time, if there's really heavy file system contention, then it's not going to stall the rest of the website while it's waiting for this. And like, it's not going to stall our program at all, in fact, because it's just going to do that in the background and then continue on when that comes back. Because again, Tokyo's done all this work to make that work quite nicely. So now we have a file. Paste open, stream into @mute file. Now, this probably needs to be marked. Right, and now it says, oh, this is quite interesting. By the way, so there's a warning here. Futures don't do anything unless you dot, await, or poll them. Stream2 is an async function. So this operation here, like streaming the data into this new file, is going to be asynchronous as well. And so we want to wait for that to finish before we continue. There's also going to be some kind of result, and we'll just, we'll say expect the data, the file should be fine to write to with the data. This could maybe like fail if we ran out of disk space or something like that, but I'm no longer at 95%. I've gone and cleaned some stuff up, so that's pretty nice. Yeah, and so now we've got 2 await points. And if we went back to the example, there's another sort of state in the middle now, where it's like representing, you know, the next future that we're sort of waiting on at a certain point. Oh, stream. There's a typo in the doc's PR time. Stream. Got him. That's good. Well done. Well spotted. Okay, cool. And so now we've stored the paste in that file. We'd probably also like to tell them like the paste that they got back. Maybe we'd like to do this with something like JSON. JSON's a nicely consumable data format. People seem to like JSON. So let's throw JSON in there. Version is this. Features is JSON. Cool. Let's use JSON. Is there... see JSON for details. Great. JSON of some type. Cool. I don't know. We might need to pull in Surdy as well. I'm not 100% sure. I guess we'll find out. So we could say something like struct create paste response, where it says paste ID is a... I mean, we could do a string here, but I think we could even just put a paste ID in there like straight away. I think the deserialize would honestly be fine for this. That is assuming the deserialize for UID chooses to deserialize into a string, but I bet it probably would. Bytes. Oh, it's up in the air. Oh, they probably implement it manually. Let's double check. This seems interesting enough. So let's see, struct UUID. How does it implement serialize, deserialize? Or does it even? Okay, it seems it does. And it seems, sometimes it deserializes a string, sometimes it's bytes, but JSON doesn't really support bytes anyway, so it probably turns that into some sort of string regardless. Whatever, let's not think about it too much then. Let's just write it as a string. So paste ID here is going to be a string. We'll derive serialize and deserialize. Rocket seems to re-export those for us, which is nice. Nope, it doesn't seem to. It seems like that's busted. So that's fine. We'll just add in Surdy ourselves. Cargo add Surdy, our favorite, and also with the feature Surdy derive, like that. And then this here is going to be, we'll grab those and use Surdy serialize, deserialize. Hooray! What is this? Unresolved extern crate. That seems like it's freaking out over nothing. Yep, it decided it's happy. Cool. And so now we could just say here, we'd like to return back JSON of a create paste response, like that. And it's going to go, oh my God, it's not returning a JSON of create paste response. Yeah, I know, we just haven't done it yet. It's fine. Create paste response where the paste ID is paste ID dot, I guess we're just going to call toString on this. So we'll say impl display for paste ID, function format, let's, whatever, we'll leave it as that. self.0format with F, like that. So we're just saying in order to display a paste ID, just display the UUID, like turn it into a string. Display nicely gives us the toString trait for free, so paste ID is now just paste ID to string, like that. Cool, and we've written an async function that does things nicely, concurrently, that kind of thing. Uses Tokyo file and this Rocket Stream 2 futures. And again, these are like concurrent operations, but they all just work under the same interface, which is again really nice, a really nice part of futures, in my opinion. Okay, so let's see. The server is launched. Let's try and make a paste. So I'm going to do this with curl. It's generally easiest if I just make a file first. So I'm going to make my paste.txt that says hello from COMP6991, like that. Then we're going to say, where is, here. We'll write curl this URL here. No, not that URL. In fact, we want /create is what we've called it. Actually, we're going to need to add the route as well. Create paste like this. So it's going to be on /create. It's also going to be a post. And we want to pass it mypaste.txt like this. So call this URL with all of that. And what we get back is paste ID is this. And in pastes, hey, we see a file here. Hello from COMP6991. Oh no, lag? No, wait, but it seems fine now. Oh, it's every time at like 7:30, 7:40. Even though I have very good internet. I pay the big bucks for very good internet. Anyway, I can only assume it seems fine now, because it says it's fine now. Is it fine now? No one in the chat has said actually it's okay now. It seems okay on my end, again. No? Yes? Fine now? Okay, okay. All right. It's okay, I think. Okay, cool. So anyway, the good news is I ran this query here, post with mypaste.txt, and it said, here's your UID. And over here, we got the hello from COMP6991, which is the bytes that I sent it. So that worked fantastic. And again, it should be highly concurrent and amazing. 20 seconds behind. I see. Okay, awesome. I mean, like, not awesome, but at least it's better than being infinitely behind, I suppose. Still catching up. Okay. So that's great. Now we really need a way to get the pastes back as well. That seems pretty sensible. So let's write something like this. A get URL, which is like, I mean, we could even call it get, or yeah, get, I guess. I don't have a better idea than get. I'll leave get for now. And we'd like to take in like the paste ID as well in this URL. Paste ID. Well, you know, I could go use a string, that kind of thing again, but like, why not take a paste ID in? Right? Why not take a paste ID in? We're going to have to do some work because it's going to go, hey, I don't know how to like use this. I don't know how to necessarily like use this as a parameter, but that's just going to end up being something like a trait implementation. So we'd like to say, okay, I'd like to be able to use paste ID. The fact that I'm taking a paste ID means that it must be a valid UUID because it holds UUID. You know, we get all this really nice type safety, which is great. So it can't just be any random string anymore. And so now let's write a little bit of code. Impl from param for a paste ID. So from param tick A, let a paste ID be used as a website HTTP post just parameter in general. And I am going to need to say if there is an error, we'll give you back, say, a string from param. So we get a string, which it's calling tick A, which is not a lifetime. I guess I probably need tick A, and tick A. And then we return back a result, either with a paste ID or an error that went wrong. So for us, that's going to look like, would like to create a UUID. So UUID from, let's see, is there a from string? Yes. Yes, that seems good. Oh, from string just means from string. Whatever, we'll try it out with this parameter. And then if there is an error, if it goes well, if we have a UUID, then we can just turn that into a paste ID of that UUID. If there is an error, then we'll ignore whatever they say the error is, and we'll just say string from invalid paste ID, not a UUID v4. Something like that. Great, and all the types check, and it's happy now. And so now, if we go down here, we can just use a paste ID here, and Rocket will use that implementation that we've written, which is again very awesome. We'd also probably like to give them back the paste. String is maybe not the best, like the correct thing to use here. In fact, I believe that Rocket knows how to just spit out the contents of a file. But we might need to use a slightly different file. We might need to say, I think Rocket has or maybe it knows how to just use a Tokyo file. We'll try it out. Just say give a file, and we'll make this an option. Like if we could say give a file, but now, as we know in Rust, we're always gonna have to give it a file, even if this paste ID is maybe a valid ID, but doesn't actually correspond to a real file. So we'd like to say option. We'll throw a to-do at the bottom so we don't end up with these huge errors. And, well, I mean, the good news here is that, like, paste ID, we can now do paste ID dot paste to path. So let path be this. And we don't need to do any further checking because we know that this is always going to be an okay path. Because /paste is fine. And then this, like, I mean, we don't need to do, like, security checking and stuff. And this UID is only ever just going to be like these bytes that are in a UID. We've already checked all this stuff in, the parameters and the types. And so we can just say like, file open the path, and that's going to be a future, right? So, okay, we need to await opening the file. We can't call await because we're in a normal, we need to make it async, this is sort of the pattern you go through. And then this gives us a result, and like if there's an error, it's probably that the file's not there. We can just use .ok, which is a nice function on result that just turns it into an option. It just like changes the error variant. If you haven't seen OK before, you've been living under a rock. No, result here has a nice function OK, which just says when you call result.ok, it turns it into an option instead. Just forgetting whatever the error is, discarding the error into just a none. And that satisfies our types, and to me seems to hopefully, like and Rocket would have a type error right now if it didn't know how to deal with the file. Like if I just give it some random type, struct foo, and then I give it back, say, an option of foo, and I comment this all out and just like leave the implementation blank, we'll see that it doesn't, like Rocket won't respond with a foo because it doesn't implement this responder trait. Again, I think it's a really nicely implemented library that makes great use of what Rust has to offer. And so we'll get a compiler error if it doesn't really know what to do with that type. So the fact that it, you know, I was a little worried earlier, is it going to know how to deal with a Tokyo file? The fact that it's compiling tells me, yeah, it does. So like, we're sorted. Retrieve paste. We don't need the struct foo, do we? And I mean, let's try it out. So I guess let's even create a second paste here. And we'll see now we have 2 pastes that say hello from COMP6991. And I'll grab this UID, and I'm hoping that I can then say curl, create, not create anymore. It's going to be /get/ the paste ID here. And it spits out hello from COMP6991. Yay! What if it's like what if it's one that doesn't exist? Then we get 404 not found. And I can tell Rocket to do my own 404 like kind of error that's maybe not HTML or something like that, but you know, this is fine too. Like this hopefully gets the message across. We could even make this be JSON or something like that, like the other one, and if that's what we wanted, but you know, this seems to work fine. So yeah, welcome to 691 Pasters. And in here we could grab it, you know, a UID that had been given back in a response, get this, and there it is. And we've made our own paste bin with async rust and concurrency, and it was, I think, not too bad. And it's, I think, like a pretty reliable solution, making pretty good use of types. I didn't actually talk about this much before, but I really like things like this. Rocket's written a attribute macro that generates code from like this, the like annotations that, you know, things like Flask and stuff look like. So I mean, I think I might be able to say, Tom's the expert on cargo expand, and he was teaching me, I think I can do something like this. So just show me what the macro output of this function here is, retrieve paste. Probably gonna have to recompile it in nightly. So again, I get a nice little slap of warmth in the room while it compiles all the Rust code again. Cool. And does it actually, I guess it doesn't, where does this code end up? Paste ID, paste to path, file open await, okay. Rocket code generated proxy structure. Oh, okay. So I think cargo expand is not really seeing it. We can expand the whole thing, but I'm worried that it's going to be a lot of output, but maybe we can sift through it quickly just to see like roughly what it does with this get thing here. Here we go. So here's what it seems to do. So we have our retrieve paste function. Then it generates this struct retrieve paste, impl retrieve paste, and spits out all this code, parameter guard of paste ID and blah, blah, blah. You know, wow, okay, lots of interesting stuff. Static info, right, so it puts that URI in a struct somewhere, the get paste ID that we'd like here. And, you know, this might look really kind of nasty, the fact that it's spitting out all this stuff here, and like, what if something goes wrong in there? But the thing that should bring a little bit of like, oh, okay, it's probably okay back is the fact that, you know, all this is going to get sent through the Rust compiler anyway. And we know the Rust compiler is really picky. So if it spits out code that's, you know, wrong or, you know, isn't going to work, there's a good chance that the compiler is able to catch something like that anyway, because it all gets fed back through, as opposed to this whole process being something that runs at runtime that might panic or go wrong, you know. So yeah, but that's pretty cool. Making use of macros to, like, you can definitely make use of macros to make your code a lot more complicated. No one's really getting gold medals for doing that because that's easy. But making use of macros to make writing code a lot simpler is certainly, you know, is a nice clap to Rocket for that one from me. But yeah, that's our paste bin. I guess I'll delete one of these pastes here. Excuse me. But yeah, I mean, that's like, this is, I mean, I guess one thing we could look at is using, like, we didn't get to use Tokyo ourselves. I think, do I use Tokyo ourselves in the course infra? Because I have this feeling that I didn't do it this way. Right, I do have, I make my own main function. I guess we can try and see that. So I write rocket main async function main result of unit or rocket error. And then I say, I'm gonna yoink some of this. The website is starting. Let me rocket is rocket build mount like that. And then rocket.launch.await. And then okay, like that. What does this return? Result of rocket ignite. Okay, and I guess we don't care about that. So if you, like, there was a little bit of magic going on there before. This doesn't need to be mutable. Apparently it does need to be on, because I do some other tricky stuff in the course infra. Right, and so this is like sort of pulling the hood back here. This is essentially the same as using Tokyo main, but I'm guessing, let's see if rocket Tokyo main works. Okay. So Tokyo, it expects that Tokyo exists. I could just quickly fix this. Oops, no, not Tokyo. And it's maybe happy. Yeah, now it's happy. So like, this is like literally creating an async program with the Tokyo runtime. With the Tokyo runtime, I spin up Rocket and then launch that. And Rocket handles like delegating the requests down to these async functions. Tokyo deals with all the scheduling and executing and event looping and all that over all these requests and stuff. And at the end of the day, I get this website would be really fast. Genuinely. Like if I wrote this code with Flask in Python and then I wrote, I have this version here, Rocket and Rust, and I deployed them onto like the same server in the cloud, the amount of concurrent people making, creating pastes and retrieving pastes, you'd probably see a relatively sizable difference in the capacity of each of these servers. And where I think we'd be leveraging the computer probably much more, probably in a more powerful way than would be, than would be easily feasible in languages where concurrency is a little harder to express safely, to express in a way where you're not super worried that you've made a mistake, that kind of thing. So yeah, fearless concurrency, fearless, and in this case I think pretty easy concurrency. It like the compiler pretty much was able to guide us through whenever we needed an async or an await. We just go like, call this and do some stuff. Oh, you need an await here. Okay, put the await there. Oh, your function needs to be async. Okay, make the function async. And like, okay, cool, it's working now. So yeah, anyway, pretty cool. Yeah, so that's it then. I mean, that's like, this was the last like sort of cool little project that I wanted to, oh, I see. Rocket doesn't, warning, Rocket is executing inside of a custom runtime. Use Rocket main of okay, fine. Rocket main. You happy? That's basically the last little project that I thought would be a little bit of fun. I'll push it up to Git. I will. Oh, right. I just didn't scroll it far enough. Yep. I'll push it up to Git. And that's it. No. Everyone's got to start crying now. I mean, that's it. Like, this is what async Rust looks like. This is me doing like a real world project in async Rust. Yeah, it's like, there's still things to be improved with async Rust. So for example, things like defining a trait foo that says, instead of saying function foo needs to take a string like and return a string like this, whatever, saying that you would like to, they must implement an async function is not something that's possible in the language yet. There are sneaky little hacks around this where people have written macros. Rocket, again, is just re-exporting the macro from, it's one of David Tolnay's creations. Async trait, like this. And like you can just, we throw async trait on this and now async functions work, but not quite as well as they will once the language properly supports them. So there is still, the language is still moving forward and improving and working on features that are quite important for like the an entirely optimal developer experience. But most of the stuff is there, and it's I think pretty pleasing to write in general. What would you recommend as resources to further learn Rust to go after this course? Yeah, so I think we should start a forum thread on this, to be honest, because I'm not going to be able to adequately answer this question. I mean, to a degree that I find is adequate, right now. One thing that we recommend in the course outline, at the very least, is resources for students. Now that we're at the end of this course, I can very strongly recommend, for example, these two books here. So there's a book called Rust in Action by Tim McNamara, which is a nice book sort of towards the lower level of Rust, building a database, an operating system kernel, a CPU emulator, this kind of stuff, and is a pretty well-loved book. But especially now, at this point more than ever, Rust for Rustaceans is also a really nice pick. Idiomatic Programming for Experienced Developers by our favorite John Jangset. It's like a more complex reading, but I'd say you're probably coming out of this course as like relatively intermediate Rust programmers. There's there's always a ton of stuff to learn and all that as time goes on, and I'm still learning as well. But this is a great book to sort of continue on with what we've been learning. Types, designing interfaces, error handling, project structure, asynchronous, unsafe, concurrency, and parallelism. I mean, we've talked about these kinds of things, but John really goes into a lot of depth and talks, it talks to a degree that we would aspire to talk about in this course as well. And David Tolnay also was the technical reviewer of this book. David Tolnay, who is famous in the cover. David Tolnay, who is famous in the Rust community for having written things like Surdy or async trait or sin or quote. Oh no, the stream is dying. No, buffers in the chat. No. Okay, and it's fine. It's back. But one thing that I can definitely recommend, really, YouTube really wants this to end, is John, who has written this book, also makes a lot of fantastic videos. That's a fun thumbnail right there. Some fantastic videos, a lot of which are sort of aimed at Rust, like that sort of Rust intermediate level. In particular, Crust of Rust is a fantastic series. Crust of Rust, 15 matches. Yeah, that's probably all of them. There's 15 episodes of Crust of Rust. They're usually somewhere between 1 and 3 hours long. Just like go looking through the Crust of Rust spits and see if there's any that are of particular interest to you. So like, oh, I liked FFI, or send and sync were interesting to me, or async await, or functions, closures, traits, atomics, dynamic dispatch, like din traits, the drop check. And this is like unsafe stuff here as well. Even this one, sorting algorithms, is just like John goes through and implements a bunch of sorting algorithms in Rust in a way that he feels is idiomatic, that kind of thing. And there's new YouTube emotes. Wow, nice. So yeah, this is also another massive recommendation from me. John's channel is fantastic. And I know it doesn't say I'm subscribed, but I opened a private window, so I don't leak all of my YouTube stuff. How do we study for the exam? I would suggest studying by doing the practice exam. is a very good start. So do that. The week 10 exercises where you can find it. I would also really strongly recommend coming to the workshops this week. Because have we released the workshop yet? Yes, we have. the workshop 10 is literally exam prep. And you're going to be like coming up with questions and doing sample questions and that kind of thing. If you're like, wanting to prepare a little more for the exam, make sure you come to the workshops, because that's what the last workshop rather, because that's what the last workshop is all about. So for Tom. Oh yeah, we have fun, don't we? Oh yeah, okay. Is there any? Oh boy, okay. I think that's fake data from one of the exercises, but I'm just gonna like play it safe. Workshop 10 1511. What? Oh, git pull. All right. Damn it, Tom. Lecture chat caught you, Tom. All right, there you go. Fixed. Cool. All right. Back to C. Yeah, back to C. Cool. So, that marks the end of our last lecture. It has been an absolute pleasure through the ups and the downs, delivering these lectures over the term. Thank you for the people who sort of stuck with it. It's funny with online lectures. I'm always like, oh, there's, it's very nice having some people here to interact with every week. And I'm like, oh, but it's usually only like, 5 to 10 out of the 85 students or so showing up consistently. But then I look at a few days later, I'm like, okay, it's got like 150 views now. Like, okay, that's, like, I think people, at least maybe like a subset, maybe like half the course, engaging with the lectures. But, thank you in particular to all of you who have been, have been showing up to the lectures throughout the term. And if you're watching the recordings, then thank you for watching them as well. And hopefully they were somewhat enjoyable. Why is this? What is going on here? Oh no, he hasn't terminated his list. Oh, this wouldn't happen in Rust. No. Oh, that's really funny. Oh. But yes, thank you very much, everyone, for coming to the lectures. And /li. No. But yeah, I hope it was interesting and fun. Got you again, Tom. It's a linked list. Yes, it does look a lot like a linked list. Yeah, I think we've had a lot of fun this term. But I mean, ask as many questions as you'd like on the forum. One thing we're going to recommend as well is feel free. Maybe we'll put a timer on this. Well, I mean, I guess maybe we'll make a category on the forum. That seems like the appropriate thing to do. We'll make a category on the forum to feedback, exercise, broken memes, workshops, lectures. Yeah, so we'll make a new category called exam or something. And you can like post like questions and answers. So you can ask questions about the exam, but also we'll be fine with you in terms of the practice exam. This is going, hey, this was my like written answer for prac exam question for part 3 or whatever. And ask for feedback, and then you can post your question and maybe have a look at a couple other students and give your own feedback and sort of, make this nice little arrangement where everyone can give feedback on each other's answers, and we'll come in as well and offer some thoughts as well. So yeah, that's another good thing to do in terms of prepping for the exam. We'll make another category for that. So thanks for the work. And thanks to the rest of the team. I shouldn't need to be reminded about that, but a massive thanks as well goes out to the rest of the teaching team. Tom, Shrey, who was disappeared at the very end, but was here for the vast majority of it. And then our teaching staff, Kai, Sage, and Jared. A very big thank you to everyone who has been helping make this possible. And I am excited to see like, I guess 3/4 of you in the last workshops, because I'm not in the online one, but I end up seeing, I think, the rest of the students. So we'll see you all then in the workshops, and yeah, I guess that's it. Thanks everyone. Yeah, keep up the chat on the forum, and we'll be around. And thank you for what has been a very, very fun term. Yeah, all right. We'll see you later in the week in the workshops. Bye, everyone. See you all later.